Hi everyone, welcome back to Lulumath. This video is on how to solve two-step equations, and the background knowledge you'll need is you'll need to know how to solve one-step equations, and if you need a refresher, there is a video on that at lulumath.com as well as the Lulumath YouTube channel. So a little tip before we actually go into some examples is when we solve equations, it's always easiest if we get the variables on one side of the equation and the constants on the other side of the equation. And I'll explain to you what I mean by that in our first example. So here we want to solve for y, and 6y minus 7 equals 25. And we've got our two sides of our equation. We've got the 6y minus 7 on one side, and then we've got the 25 on the other side, because don't forget your equal sign is what separates our sides of our equation. Now, the 6y is our variable. This negative 7 and this 25 are our constants. They don't have variables on it. And they're called constants because negative 7 will always be negative 7, 25 will always be 25, but 6y will change depending on what y is. And looking at the left side of my equation, I see I have variables and constants. It would make sense for me to only have variables on the left side of my equation, which means that I'm going to try to get rid of this negative 7 that we see here. Well, how do I get rid of it? Well, the opposite of subtracting 7 is adding 7. So I'm going to add 7 to cancel it out, because negative 7 plus 7 is 0. And remember, 6y plus 0 is just simply 6y. So this is nice. I will just have a 6y left over. The plus 0 is not necessary, so I'm not going to include that because, again, 6y plus 0 is just 6y. But an equation is a balance. Whatever I do to one side, I have to do to the other side to keep my equation balanced. So I'm going to add 7 to this side right here, and I end up getting 32. So if you can see here, I now have variables only on the left side and constants only on the right side. So now I'm at a place where it's so much easier for me to solve my equation. But I haven't fully solved my equation because I haven't figured out what just y is. I figured out what 6y is. So now I need to get rid of this 6. Well, this says 6 times y, so the opposite of multiplication is division. So I'm going to divide by 6, and 6 divided by 6, quote unquote, cancels out to give me 1, so I get 1y, but 1 times y is just simply y. So I can just write down that this is y. But whatever I do to one side, I have to do to the other side. So I get 32 over 6. Now, quick note, 32 is not evenly divisible by 6. So I can't divide this out evenly, but I can simplify my answer because they're both divisible by 2. They're both even numbers. So 32 divided by 2 and 6 divided by 2 will give me 16 and 3 respectively. So that means that my final answer here is 16 over 3. And that's how we do this example. Now, one quick note that I would like to make is you don't have to get the variables on one side and the constants on the other side if you don't want to. I just like to do it this way because I find that it's easier, because essentially what we're doing is we're working backwards using the order of operations. Since we're solving equations, we're undoing everything. So according to order of operations, depending on where it is you are located, you could either have BEDMAS or PEMDAS. We always do brackets or parentheses first, then exponents, then division and multiplication, and then addition and subtraction. But when we're solving equations, we work backwards. We always undo everything. So since we have multiplication here and subtraction, we get rid of the subtraction first because it's easier for us, but it's not required. Let me show you how it would look to solve this equation by getting rid of the 6 first. So I would divide by 6 to get rid of it first, but I would have to divide everything by 6. And 6 divided by 6 cancels out, so I get y minus 7 over 6 equals 25 over 6. Well, now I need to get this y alone, so I need to get rid of this minus 7 over 6. So I'm going to add 7 over 6 to cancel it out. So I end up getting 25 over 6 plus 7 over 6 is 32 over 6, which is what we got here, which brings us back to this 16 over 3. Now, either way is totally fine for you to solve, But for me personally, I personally prefer to solve it this way. And that's how I'm going to go through and show the rest of these questions. But if you prefer this method, you can solve the rest of these equations using this method. The biggest thing though is you have to remember to divide every single term and not just the 6y and the 25. Let's take a look at this next example. It says 3 minus h equals 10. So here we have a constant of 3 and another constant of 10, but they're on opposite sides of my equation, and I have a variable of negative h. So seeing that I only have variables on the left side, that means I don't want constants on the left side. So I'm going to get rid of this 3 that we see here. Now be really careful because a lot of people will say, oh, there's a minus sign there, so I'm going to add 3 to cancel it out. But this doesn't work because 3 plus 3 is 6. It doesn't cancel it out. It's not going to give us 0, and 0 is what we're looking for. So instead, I need to get rid of a positive 3 by subtracting 3. So 3 minus 3 gives me 0, which is exactly what I'm looking for. So this is the correct way to do it. Well, whatever I do to the left side, I also need to do to the right side. So I'm going to subtract 3 from the right side. So 10 minus 3 gives me 7. So my right side of my equation has a 7 on it. The left side of my equation has an h, but a common mistake that people will make was they'll just say it's h and they'll totally forget that that minus sign is there. But the minus sign is for the h and not for the 3, which is another reason why we shouldn't be adding 3 to cancel that out. So this negative has to get dragged down. So this is negative h. Well, I don't want to know what negative h is. I want to know what positive h is. So I have to think, well, there's an invisible coefficient of 1 in front of this h. So it's negative 1 times h. And the opposite of multiplication is division. So I'm going to divide both sides by negative 1. And negative 1 divided by negative 1 is positive 1, which is what I want. So I get positive 1h, or just simply h. And then 7 divided by negative 1 is negative 7. Also, just a quick note, is that if negative h equals 7, then it might be a natural conclusion that positive h should equal negative 7. And that's my answer to this question. All right, let's take a look at this next example. 11 minus u divided by 5 is equal to 2. We have our variables here, and the minus sign is for our variable because it comes before the variable. And then we have our constants of 11 and 2. And the left side of my equation is 11 minus u over 5, and the other side, or the right side of my equation, is 2. So because I only have variables on the left side, I'm going to want to get rid of the constants on the left side. Now, in the last few examples that we've looked at, we've always gotten rid of the constants on the left side, but that doesn't necessarily mean that that's always what we have to do, okay? So I'm going to get rid of this positive 11, and the opposite of a positive 11 is a negative 11. So I'm going to subtract 11 from both sides. Remember, whatever I do to one side, I do to the other side. Also remember that this minus sign is for the u over 5 and not for the 11. If we see this minus sign, some of us will accidentally think that we should add 11, but 11 plus 11 does not cancel out to give us 0. It actually gives us 22, so be careful of that. So 11 minus 11 is 0, which is what we want. So we have negative u over 5 equals, and then 2 minus 11 is negative 9. Now at this point, my goal is to get the u alone, remember? So I want to get rid of this 5, but I also want to get rid of this negative. So because this is division, I'm going to do the opposite of division, which is multiplication. So I'm going to multiply by 5. So this 5 and this 5 cancel, but then I'd be left over with a negative, which is not what I want. So I'm going to multiply by negative 5 because negative times negative cancels out to give me positive, so I end up getting a positive u left over. Well, whatever I do to one side, I have to do to the other side, so I'm going to multiply by negative 5 on the right side. And negative 9 times negative 5 is positive 45, so 45 is my answer to this question right here. Okay, in our last example, we have our two sides of our equation. We've got the 2.1 is one side, and then the other side is 0.8b plus 4.92. And looking at this here, we can see that 2.1 is a constant as well as 4.92, and that 0.8b is our variable. Now this time our variable is on the right side, so we want to get rid of the constants on the right side so we can have variables on one side and constants on the other side. So I'm going to start by trying to get rid of this 4.92. Because it's positive, I'm going to subtract 4.92. But whatever I do to one side, I need to do to the other side of my equation. So when I subtract 4.92 from 2.1, I get negative 2.82. And that's equal to 0.8b. I just bring down that 0.8. Now, to get that b completely alone, I need to get rid of this 0.8. Well, it's being multiplied, so the opposite of multiplication is division. So I'm going to divide both sides by 0.8. And because 0.8 divided by 0.8 is 1, I get 1b, or just simply b. And then negative 2.82 divided by 0.8 is negative 3.525. And this is my final answer. That's it for this video. If you have any questions, let us know in the comments below or at lulumath.com, where you can find blank or completed notes for this video. If you found this video useful, please make sure to subscribe and share with others. Thank you, and we'll catch you next time. Bye.